This is video 3.1. It deals with static electricity. Now, static, as its name implies, means not moving, although there has to be a little bit of movement beforehand. It's all to do with electrons moving. So electrons arriving makes something negative, electrons leaving makes something positive. It's in contrast to current electricity, which is constantly moving. So that's where the word static comes from. It's also related to the idea of something being charged and the idea of a field. So a field is an area, a charged object means it can exert a force. That's all it really means. And we're going to be looking at some uses and some dangers. So here we have the starting point again. Matter has the property charge. What does that mean? It means it can exert a force. So there are three fundamental particles. The green ones here are neutrons. They are not charged. They cannot exert a force. But the black ones, the protons and the electrons, can. Now, normally these two, the protons and the electrons, balance out exactly. So 3 and 3 in this case. So the vast majority of time, substances you deal with are neutral. They do not exert forces. It's unusual for them to do so. But at a fundamental level, we must remember that they can. So electrons will repel each other, two red circles here moving apart. The protons will repel each other given the chance, and they will attract the opposite kind. Now, the heart of this whole topic really, as we said, is electrons moving. So here we have our two materials here again. To begin with, they're neutral, and when the electrons move from left to right, the one on the left becomes positive. So here we can see neutral vanishing, the word neutral vanishing. The electrons, you can see, are moving across. Now this is positive because there is one more proton. The extra proton can express itself, if you like. And down here we can see protons are now more numerous than electrons. And the opposite's happening over here. Electrons are now more numerous. And we say overall that the object is negative and they will attract each other. So certain materials such as plastics are insulators. They hold on to electrons very well once they've arrived, and hair also comes into that category, and that's why we get sticking up hair, because the hair is repelling itself. We also get something called induced charge, which we can see here. So this object here is actually neutral to begin with, 4 and 4, but when we introduce a negative object here, it's been flooded with electrons, they move away and it leaves this side positive, and this is why balloons can stick to walls. Now, static can be very useful. Here in a chimney, it's used to extract soot. So here we have the soot uncharged. It goes through the grill, picks up a negative charge, and it's attracted to these plates where it's later removed, and so less of it goes into the environment. Over here on the right, we've got spray painting. So this green paint is charged up, can be positive or negative, creates a nice fine spray, doesn't get clotted, so it produces an even coat. It's attracted to this object because the object has the opposite charge, and it wants to get there. So it'll actually turn back on itself because it's attracted to the other side. So it's a better way of spray painting. There are also dangers. So here we have a plane. It can pick up a negative or a positive charge. Remember, in both those cases we are dealing with electrons moving, so picking up a positive charge means losing electrons. It does not mean picking up protons. Now, normally we would earth it, so this wire here is attached and all the electrons, or the excess electrons, flow away, or if there is a lack of them, they flow back in and we can have safe refueling. If that doesn't happen, there's a danger of an explosion because we've got oxygen in the air, fuel vapor, and the spark can generate heat. So it's a classic sort of 5-mark question, and you really have to explain those three elements. Heat from the spark, and where does the spark come? It comes from the discharge. So finally then, we've got the idea of field. So a field just means an area where force is experienced. So really it's just an elaboration of the earlier diagram. So here we've got an electron and it has a field around it. The direction of the field is defined by the direction a positive charge would move. So here we've got the positive charge comes in, the negative charge is repelled away, and the opposite is happening on this side.